Yes, let's start. Today we will mention a variation of parameters, this method, and this method is the general method for a particular solution of the non-homogeneous equation to find for the given second-order differential equation. For example, take the second order differential equation here, and we know that L of y is a linear operator, and L of y is y double prime plus p of t y prime plus g of t is q of t, y is g of t. It's okay. And with and the homogeneous, the general solution of the homogeneous part is C1 y sub 1, C2 y sub 2, and this one is the general solution of course, homogeneous differential equation means L of y is 0. It's okay. Consider this differential equation. What can you say about this differential equation? And this differential equation non-homogeneous and the second order differential equation. And here, be careful. And this one is the coefficients. Look at the coefficients and also consider these and the differential equation. Look at this differential equation. Y double prime coefficient 1 standard form means it's okay. Our second order differential equation standard form, and look at the coefficient of y prime p of t, coefficient of y q of t, and means and these coefficients are the function of t. It's okay, function of t. So and our look at the homogeneous part, and means this one is 0, but and not this one is a not constant function. So and this one is valid for also constant functions and also non-constant functions if p of t and q of t are a function of t. It's okay. So and our aim, of course, if our and the our differential equation non-homogeneous, g of t not 0, so our aim is to find the particular solution of the our homogeneous non-homogeneous equation. It's okay. Sorry. So now assume that particular solution is u1 y sub 1, u2 y sub 2 with this assumption that this assumption y, and there's a typo here, u1 prime y sub 1 plus u2 prime y sub 2 is 0. So our aim is to find the y sub p, and means and find u1 u2. It's okay, and it's such that and the u1 and u2 and satisfy this equation. It's okay, equation. So how to find the u1 u2 here? u1 u2 we have two unknown, and so to find the two unknown, if we have and the two equation, two unknown, so yes, we can obtain the these and the unknowns, and here one equation is okay, one equation, and also we know that y sub p, our aim is to get the particular solution, and particular solution means satisfy our differential equation, and means write the here y sub p double prime, y sub p prime, y sub p should be g of t, because y sub p, our aim is to find the y sub p such that y sub p should be particular solution, and means satisfy this equation. It's okay. So and here we claim that y sub p should be this one, so substitute here, so and we obtain and write here L of u1 y sub 1 plus u2 y sub 2 is equal g of t, should be. So and compute the yp double prime and yp prime and write here, so this one should be g of t. So we write and then we obtain and another equation. u1 prime y sub and y sub 1 prime plus u2 prime y sub 2 prime is equal g of t. We have this equation first, and then we obtain the second equation here. It's okay. So, and we obtain the linear system. It's okay. This one is a system. So, and we obtain this system, and we know when the 2 by 2 system, and the unknown here, unknowns here, u1 prime, u2 prime. It's okay. So, and if we get the u1 prime, u2 prime derivative of the unknowns, so it is possible, it is easy to get the u1, u2. How to get? Integrating both sides, and we obtain the u1 and u2. It's okay. So, but here we claim that, use a different color, maybe it will be better. This one, our aim is to find u1 and u2. It's okay. And here we get this system, and solve this system. We obtain u1 prime, u2 prime, and then integrating both sides, so we obtain u1 and u2. And also, we claim that and also here, y sub 1 and y sub 2 and the Wronskian determinant non-zero, because what is the reason here? And this one is, we claim that L of, and the second order differential equation, this one here, this one, if we have the homogeneous, the general solution of homogeneous part, means we have y sub 1 and y sub 2. We know that y sub 1 and y sub 2 are fundamental. Are fundamental means Wronskian determinant y sub 1, y sub 2 not zero. It's okay, not zero. So this one is not zero. This one is not zero. What does it mean, this one? This one is not zero, and means right here, y sub 1, y sub 2. What's the Wronskian determinant? Y sub 1 prime, y sub 2 prime, not zero. Look at our system. Our aim is to get solve this system, and look at the how to solve this system. And this system has a solution. What's the condition here? Use a different color. And our aim is to get this one. Look at the coefficient. This one. Coefficient, determinant of coefficient, determinant of the coefficients should be non-zero. And should be non-zero, so this one has a solution, unique solution. Means, and u1 prime coefficients, u1 prime, y sub 1. Coefficient of u2 prime, y sub 2, u1 prime, coefficient of u1 prime, y sub 1 prime, y sub 2 prime. It's okay. So this one should be non-zero. If this one should be non-zero, yes, this one here non-zero, because Wronskian determinant is 1. We know that y sub 1 and y sub 2 fundamentals, so Wronskian not zero. Wronskian's determinant here, the coefficient of star equation. So yes, we can obtain u1 prime, u2 prime. So integrating both sides, so we obtain the value of u1 and u2. It's okay. So, and we got the particular solution. What's the particular solution? Is this one? Yes. Any question about the this one? It's okay. How to get the particular solution using the variation of parameters? It's okay. And this one is called, this method is called the variation of parameters. To understand this and the method, let's give an example. It's okay. It will be better to understand this method. So, and we have some example from your book. It's okay. And the first one, solve this differential equation. Y double prime plus 4y plus is equal to cosecant t. And the right hand side not zero, non-homogeneous. Second order differential equation. And also constant coefficients. Is it in the standard form? Yes, this one is in the standard form. It's okay. So this one is second order non-homogeneous equation. So, and I have to solve this differential equation. It's okay, this differential equation. So write the first step, write the homogeneous part, first step. Find the general solution of homogeneous part. First step, step 1. And step 2, find the particular solution of the non-homogeneous equation. So how to find the particular solution? Look at the right hand side, but the right hand side not exponential function, not polynomial, or not a trigonometric function such that contains and the second and or cosecant plus. It's okay, sum of the sine and cosine. And this one is contains and sine or cosine, but this one is a quotient of sine or cosine. It's okay. So and undeterminate coefficients and the method is not valid here. You have to use the variation or parameters to find the particular solution. Be careful. It's okay. So, and the next one, next question, and this one is page number. This one is question 1, page number, question this one. It's okay. And also page number, question 5, and the last one. So the next question, y double prime minus 5y prime plus 6y is equal this one. So, and the right hand side and the exponential. So, and we can use the undetermined coefficients method and variation of parameters to find the particular solution. It's okay. Next question, this one. It's okay. This one. So non-homogeneous, not standard form, and the second order differential equation. And also look at the homogeneous part. Take this one, not constant coefficients. It's okay. So, and of course, this one is non-homogeneous equation. First one, find the general solution of, and this one, homogeneous part, and then the next one, particular solution. But here, this one is non-homogeneous if consider the homogeneous part, but not constant coefficients. It is not possible to use the characteristic equation to find the homogeneous part, the general solution of homogeneous part. But here, question, and take the given and the equation t greater than 0, we claim that this one is this one and this one are fundamental solutions, and also particular solution this one. It's okay. The second one, solve these differential equations, second order differential equations, standard form, it's okay, and constant coefficients, right hand side non-zero, so non-homogeneous equation, but how to find the particular solution? Of course, you have to use the variation of parameters, because this one is not sine t or sine 2t or plus cosine. It's okay. This one is a quotient of sine and cosine, so it's not valid and these method undetermined coefficients here. It's okay. Now, yes, let's choose one of them. Let's solve. It's okay. Find the solution of the second order non-homogeneous equation here. It's okay. Let's consider the first one. It's okay. Right hand side cosecant t. So cosecant t, and so non-homogeneous, but you have to use these methods, variation of parameters. It's okay, variation of parameters. Find a particular solution of this one. It's okay. So this one contains is a quotient of sine or cosine. So it is not possible to use. This method is not valid for our differential equation. It's okay. So you have to use the variation of parameters to find the particular solution. So first step, step 1, find the general solution. Let's find the general solution of the homogeneous equation. Homogeneous equation, this one. It's okay. So this one is in the standard form, yes, because the coefficient of y double prime is 1. And also look at the coefficient of y prime and y is a constant. It's okay, coefficient of y. So, and constant coefficient, second order, homogeneous, constant with constant coefficient. So, how to solve this differential equation? Write the characteristic equation. This one is the characteristic equation. So, we obtain, and the second order equation, so we obtain 2 roots minus 4, we obtain plus and minus 2i, complex numbers. So, and here lambda is real part is 0 and mu is 2. So we know the general solution of homogeneous part, and we know that e to the lambda t and c1 cosine mu t plus c2 sine mu t. It's okay. Lambda is 0, so this one is 0. So e to the 0, 1. It's okay. So cosine 2t, sine 2t. So we obtain the general solution of the homogeneous part. Yes. The next step, step 2, find the particular solution of the non-homogeneous equation. It's okay. Non-homogeneous equation. So sorry, this one is complex number. Yes, how to find the particular solution? Write our differential equation as and this one. So, and right hand side this one. So you have to use the variation of parameters. So, how to write the particular solution? We claim that under this one. Look at the homogeneous part. The general solution of homogeneous part is this one. C1 y sub 1 plus C2 y sub 2. It's okay, this one. Y sub 1, this one. Y sub 2, this one. So, what's the particular solution? Look at this one. C1 and C1 and here, we know that here, C1 and C2 constants. C1 and C2 constants. It's okay. How to write the particular solution? C1 should be U1 prime. U1, sorry, plus y sub 1. C2, U2, y sub 2. Substitute and C1, U1, C2, U2. It's okay here. So we obtain particular solution. So we obtain, yes, write the C1, U1 and the C2, U2. So we obtain the particular solution. So, but here we claim that this one is a particular solution. So the next step, find the U1 and U2. It's okay here. So, but this one is particular solution, and the such that what's the assumption? And look at this one. We claim that this one is the general solution of, if we know the general solution of the homogeneous part, and construct the y sub p particular solution. How to construct? C1 C1 is equal U1 substitution, this substitution, but such that U1 prime y sub 1, U2 prime y sub 2 should be 0. It's okay. This one is a particular solution of the non-homogeneous equation such that satisfy this equation. It's okay. Let's come back. And what's this one? U1 prime, U2 prime is equal 0. It's okay, this one. So let's come back our question. So, and this one is particular solution such that, yes, U1 prime, U2 prime, this one is 0. And means, what's this one? U1 prime, y sub 1. If particular solution this one, y sub p is U1 y sub 1 plus U2 y sub 2, and we obtained this system. Which one? U1 prime y sub 1, U2 prime y sub 2 is 0, and the second equation, U1 prime y sub 1 prime plus U2 prime y sub 2 prime is equal G of t. Be careful. So we obtain this system. It's okay, but be careful. This one is our system to solve the U1 and U2 prime. But our differential equation, let's come back. And this one, look at this one. Be careful here. Use different color, and this one is critical point, important point. Our differential equations should be standard form, means y double prime, the coefficient of y double prime should be 1. This one is standard form. Look at the right side say g of t. So our system, if this one is 1, coefficient 1, so g of t, the right hand side g of t, and right, this one is g of t. First one, you have to check, and our differential equation standard form, if in this standard form, yes, look at the right hand side g of t, and this one should be right hand side. Let's come back our question. Yes, this one is in the standard form because, and the coefficient is 1, so g of t, this one. It's okay. If not in standard form, for example, this one is 2, not standard form. First rewrite is this one, y double prime plus 2y and 3 over 2 cosecant t. It's okay. This one is g of t. If the coefficient 2, not 1. It's okay. Be careful. This one is important and a point. Otherwise, we obtain and the particular solution, but not the given equation, and the different our equation, different from our equation. It's okay. So we obtain our system. U1 y sub 1 plus U2 y sub 2 is 0. Yes. And look at this one. This one is U1 prime, U2 prime is 0, first one. It's okay. So how to get the second one? And second one is, yes, take the U1 prime, derivative of this one, derivative of the y sub 1, and cosine 2 times t, and derivative of the cosine 2 times t minus 2 times sine 2t. It's okay. Derivative of the sine 2t, u2 prime, is this one, and the derivative of the second one, 2 times cosine 2 times t, and should be g of t. It's okay. 3 cosecant t. It's okay. So we obtain this system. So, and the next step, solve this system. We know, and here 2 unknown, u1 prime, u2 prime. 2 equation, 2 unknown. solve this system, and it depends on you. Choose the one and the method. And here use the Cramer's rule, because we know that and the coefficient of this system, Wronski indeterminate not zero, because fundamental solutions y sub 1 and y sub 2. Right, let's use the Cramer's rule here to find the y sub 1 prime and u1 prime, u2 prime are and this step is okay. So, and write the coefficient and matrix cosine 2 times sine 2 minus 2 times sine t, sine 2t 2 times cosine 2t. It's okay, this one coefficient matrix of the system. So, and use the so find the delta determinant of the coefficient matrix, and 2 times cosine square 2t and this one. So we know that this one is sine square plus cosine is 1. So 2 times 1. It's okay. So we obtain 2 non-zero. And this one is, we know, and because this one is the Wronski determinant and also. It's okay. So non-zero should be. If we get the 0 here, so there's a problem. Check the all computation. It's okay. So, and the next one, our aim is to find the first unknown, u1 prime. So, and you have to compute delta u1 prime. So how to find this determinant and if u1 prime, our aim. So look at the coefficient of u1 prime, and it should be right hand side. Right hand side should be the coefficient on this one. So, and it will be the first column, and the second column stays the same. So compute to this one is 0, and we obtain this product. So sine 2 times t, 2 times sine t times cosine t, and we cancel sine t, and we obtain this one. So what's the u1 prime? Delta u1 prime over delta, coefficient, determinant of the coefficient, and this one is 2, and substitute here delta u1 prime. So we obtain 3 cosine t. And we obtain u1 prime is minus 3 cosine t. Sorry. So how to get the u1? Integrating both sides. So we obtain this one. u1. It's okay. Integral minus 3 cosine t is equal minus 3 sine t plus c1. It's okay. So, and let's find it now u2 prime. It's okay. So, and first we know when the Cramer's rule, first row, first column stays the same, and the second column will be right hand side. Right hand side. Look at this one. Right hand side. This one. It's okay. So, and compute this determinant. So we obtain this one and rewrite this one and this one using the double angle formula. It's okay. So we obtain this one, So, and u2 prime, yes, u2 prime, delta u2 prime over delta. Delta is 2 here. So multiply 1 over 2, this one. So we obtain our result u2 prime. So, and we know u1 and u2 prime. Let's write the particular solution. It's okay. What's the particular solution? This one is u1. This one is plus c2, but ignore integration constant c1 and c2. And so write sorry, u2 and u2 prime in this one, integrating both sides. So we obtain and cosecant integral cosecant t. We know that cosecant t ln cosecant t plus cotangent t, and integral minus 3 sine t plus 3 cosine t plus integration constant. It's okay. And so we obtain u2. It's okay. And then use under this one, this formula here. It's okay. So u2, this one, u1, our aim is to get u2 and u1. It's okay. So, and we know the general solution of the non-homogeneous equation is the sum of the general solution of the homogeneous part plus particular solution. This one is homogeneous part, the general solution of homogeneous part. The second one, C1 should be U1, particular solution here, U1 y sub 1 plus U2 y sub 2. It's okay. So, and this one is okay. So, and y sub C1 should be U1, and the U1 is here, right? This one. But ignore and the integration constant C1 and C2, right? And the U1 minus 3 sine t times minus 3, this one, sine t times y sub 1. U2 prime, this one, y sub 2 times y sub 2, this one. It's okay. Sorry, and y sub 2 not ln cosecant t, and plus this one 3 cosine t, and this one. This one is u1, u2, sorry. It's okay. So we obtain this one and rewrite. So we obtain y sub g, this one, g, and this one is homogeneous part, this one is particular solution. It's okay. So, but we can ignore C1 and C2, and here, ignore C1 and C2. What is the reason? Yes. What's the reason? Any idea? Any idea? Because, and the reason, and this one, y sub h, c1 y sub 1 plus c2 y sub 2, and y sub p is u1 y sub 1 plus u2 y sub 2. If u1 contains c1 and c2, substitute here, it's okay, and something plus c1 times y sub 1 plus u2 is equal, and this one ln secant cosecant plus cotangent plus 3 cosine t plus c2 y sub 2, and right here, so we obtain, and this one y sub 1 plus this one y sub 2, this one plus c1 y sub 1 plus c2 y sub 2, and this one is particular solution. This one is particular solution. Look at the y sub h, this one. So, and what's the general solution? General solution, y sub h plus y sub g. So, and this part, contains the second part of the particular solution. So, we can ignore this part. It's okay? Because, and this one is C1, and here, For example, and this one is bold C1. This one is bold C2. And so, and we can write is C1 plus bold C1 is noted by capital C1. It's okay. And C2 plus bold C2, capital C2. Is okay. So we obtain, yes, this form. Means it will be better to eliminate the C1 and C2 because and the general solution and it contains all of them, these parts. Okay. So, and let's have a break, and then we will solve the given second order differential equation. This one maybe it's okay. Any question about our solution of the first differential equation? This one. Any question about the solution of our differential equation? It's okay. No question. Okay, let's stop here. Let's have a break, and then we will solve the second equation. It's okay.